This lesson is about solving quadratic trig equations. Similar to solving linear trig equations, quadratic trig equations relate directly to when you solve a quadratic equation. So in this example in the mind's eye, once again, I would have you solve this quadratic and then use that same strategy to isolate this quadratic trig function for cos x. Please go and try this now before checking to see how you did. This quadratic here is a simple trinomial. So we want to know what multiplies to minus 4 and adds to minus 3. In this case, minus 4 and 1 satisfy that requirement. Factoring, because it's a simple trinomial, we just need to put an x in front of each bracket and the number that we found with it. So x minus 4 times x minus 1 is equal to 0. Therefore, x equals 4 or 1. So when we come over to this quadratic trig function, notice that we have the same pattern. We have something squared minus 3 times that something minus 4. In this case, it was an x. In this case, it's a cos x. So we can solve it the same way. I'll still go through the process here just to show that we would do exactly the same thing. So we would do what multiplies to minus 4 and adds to minus 3. Again, we would find that that's minus 4 and 1. Cos x is our variable in this case, so cos x minus 4 and cos x plus 1 is equal to 0. Therefore, cos x equals 4, or cos x equals minus 1. Now notice this time I actually rewrote the cos x in each case, whereas I didn't over on this side. That's because there's still more work to do. We're not going to do that work here, but this is leading up to the fact that there's 2 steps to these equations. First, to solve them quadratically to isolate the trig ratio, and then finally now to solve the trig equation using our t-chart and all of the tools that come with that. So now what we're going to do is go ahead and solve some of these completely. So in this question, you want to make sure you're thinking of this in the way that you would think of a quadratic. So this sine x is under the squared, and then we have a sine x times this minus 13 and then a constant. So we need to know what 2 numbers multiply. In this case, there's a leading coefficient. So what multiplies to 5 times minus 6, which is minus 30, and what adds to minus 13. Now remember, if you're not sure what those 2 numbers are right away, you can just go ahead and write down different pairs. So you could just start writing down the pairs that you can think of, 5 and 6, 30 times 1. I'm not worrying about the sign at this point. 3 times 10. And if you can think of any more and you want to write them down, or at this point we could think about the sign. To multiply to a negative, both of these numbers have to be a different sign. To add to a negative, the largest number has to be negative. So I'm going to go through and make all the largest ones negative. So when I look at these, I don't see any yet that add to minus 13. So I'm going to see if there's any other pairs. What I don't have down here is 15 times 2. And again, the largest one has to be negative, and that does add to minus 13. So those are my 2 numbers. So now I'm going to do decomposition in the same way I would if I just had an x. 5 sine x squared minus 15 sine x plus 2 sine x minus 6 is equal to 0. Now I want a common factor between both pairs. So this first pair, a 5 will come out and a sine x. Inside the bracket, that leaves me with a sine x. Sine x times sine x is sine x squared, and then 1 times 5 is 5. That gives us that first term. 5 divides into minus 15 minus 3 times. And in the second pair, 2 goes into each of those. Plus 2 sine x minus 3 equals 0. Then I check to make sure that my brackets are the same, and they are. So that's my common factor. I will now factor out sine x minus 3. And that leaves me with a 5 sine x from the first term. This plus sign separates these two terms that are actually factored terms. So we have a 5 sine x left in this term to put here. And when we factor out the sine minus 3 in this term, we have a 2 left. So we'll put that 2 in the bracket, and that equals 0. Finally, just like when we're finding zeros, which is what we're doing here, sine x must equal 3, or 5 sine x must be minus 2. If this whole term here were minus 2, that would be minus 2 plus 2. Now you can solve these in your head. I'm just doing an extra step. So then we would divide both sides by 5, and that tells us that sine x equals minus 2/5. Now that's the quadratic part. Once we've done that, the next part is to do the trig equation and solve it. Looking at these two trig ratios, sine x equals 3 is not valid because sine has to be between -1 and 1. So this is inadmissible. That means we don't have to solve that one. That leaves us with this ratio to solve. It says it's between 0 and 360, which is one full circle. I'm going to label my axes. And I'll do my cast rule. Cos is positive here. All of them are positive here. Sine is positive here. And tan is positive here. I need to draw a line for our terminal arm where sine is negative. Sine is negative here in this quadrant, and sine is negative in this quadrant. The hypotenuse is 5 because it's always positive, so that negative does not go with the hypotenuse. And the opposite is -2. And when you do that, it's always good to make sure it matches your diagram, and that makes sense that these two lines would be negative. Now my theta will be an angle starting from the positive x-axis to there, and then another one that starts at the positive x-axis and goes all the way around to this terminal line. To know what the value of theta or beta is, I need to do the inverse sine of -2/5. I'm not going to assign it a variable because I don't know for sure whether it's going to be an acute angle or, in this case, really oblique angles. The inverse sine of -2/5 inverse sine of -2 divided by 5 equals -23.6. So in that case, that's an acute angle. What that tells us is that our beta here is 23.6. And remember, beta is not a principal angle, so it doesn't have a positive or negative rotation. It's just an angle that helps us out in these triangles in order to do this other work. So now that I know my beta, which I'm going to label in here as 23.6, now I can calculate what theta is. So theta is equal to, first of all, 180, looking at that first terminal arm, 180 degrees here plus 23.6. And that gives us 203.6 degrees. Theta also equals 360 degrees from this arm all the way around to here and then back up 23.6 degrees. And so that gives us 356.4 degrees. And that's all we need to do in order to solve that problem. Here's the consolidation question. Once again, I would encourage you just to go ahead and solve this on your own and then come back and check and see if you've done it correctly. This ratio is already, like the others were, in one ratio. Now, I'm looking at this pattern, and what I recognize is there's a perfect square here, a perfect square there with a negative in the middle, which is considered a difference of perfect squares. So I'm going to use the difference of perfect square pattern. So in the brackets, I will put the square root of each term. So we have tan 2x, and we have a 2, and we'll do the same in the second bracket. And then what we do in this kind of pattern is we put a plus and a minus in between, and that's all equal to 0. Solving that, we get tan of 2x is equal to minus 2, or the tan of 2x is equal to 2. Now that we've done the quadratic part, we want to solve each of these as trig ratio equations. And remember that with tan, because there's no hypotenuse in there, the opposite and the adjacent don't have any relationship where one is necessarily bigger than the other. So we can have values that are larger than 1 here. So both of these are admissible. So we're going to have to solve 2 questions, which means tan is negative and positive. There's 2 for each of them, which means it covers the whole Cartesian plane in every quadrant. So I will draw triangles in each of these quadrants. And I'm doing my best to try to make them the same size, since they technically are the same. And while I'm at it, I'm going to go ahead and label the sides. So I'll start with this ratio and where it's negative. So tan is negative in these 2 quadrants. So in this question here, this adjacent must be negative, and the opposite would be positive. Here, the opposite would be negative 2, and the adjacent would be 1. Then thinking about where tan is positive 2, which is the A and the T quadrants, all in tan, the opposite is positive 2, and then the adjacent is positive 1, and in this, the opposite is negative 2, and so is the adjacent, and that makes it positive overall. So now I'll do the inverse tan of each of these. inverse tan of -2 gives me minus 63 degrees, but I want my calculator in radian mode, so I'm going to switch this to radians. And then what we see is that's negative 1.11. And I'm going to go to 2 decimal places. Now let's see what happens when we do the inverse tan of positive 2. We also get 1.11. So you see that they are indeed the same. The reality is, recognizing that, we really could have just done one of these and put the related acute angle that we found in all of these. This is just a good chance to illustrate that this is true. So I will put my related acute angles in here, 1.11 in all of these. And remember, this is radians, so we don't put any units on there. It's radians understood. Before I draw my angles for 2x, I need to make sure of the proper intervals. So I have an interval for x. I need to multiply everything in this inequality by 2. 2 times 0 is 0, less than 2 times x is 2x, is less than 2 times pi is 2 pi. Therefore, to solve for 2x, I need to do one full rotation of angles. And now the last step is simply to find each of these angles that represent theta. And this last one out here. So now I'm going to solve for 2x. From this first triangle here, we see that the angle is 1.11. So that's our first answer for 2x. Then we can take pi and subtract 1.11 in order to get this angle to this terminal arm here. Pi minus 1.11 is equal to 2.03. Coming to this next terminal arm, we go pi around, and then we have 1.11 more. Pi plus 1.11 is equal to 4.25. And finally, we have 2 pi minus 1.11 equals 5.17. Now we still haven't found x. What we found is 2x. To get the final solution, what we need to do is divide this by 2 and then divide all of these angles by 2. So we end up with x being equal to 1.11 divided by 2 is 0.56. 2.03 divided by 2 is 1.02. to 5 divided by 2 is 2.13, and 5.11 divided by 2 is 2.56. And now you can go ahead and try the practice questions.